Or just to be around somebody who looked like you. Ah, crap.
Yes, indeed. Well, this is please try not to be irritating. Okay. This is Professor Tommerdahl, and welcome to our New Year's happy celebration of the perfect and unquestionable process of scientific review.
You betcha.
Which is something that both Dr. Tommerdahl and Dr. Dennis find a very effective and very pleasant process. Stop it! Stop it! Get off my chair! All right. Got rid of him again. Sorry about that. I don't know who leaves the door open. Is it you?
Well, I don't know. Who let that idiot in here?
Somebody sure is.
I think that guy probably was one of our reviewers. So.
Yeah. Today, well, first of all, happy Grumpy New Year.
You betcha.
This is our first 2019 Grumpy Science.
Yeah,
so,
all these things, top 10 lists for the year. So we thought, maybe we'd have our own top 10 list for forever.
Top something is
top
less
something,
than 10 because we want to try to keep this one short. We're going to talk about
5. Yeah.
We're talking about ridiculous scientific reviews, and I would like to go first if I may.
Oh,
and
absolutely.
I specifically haven't told Mark what I'm going to say, so I can get his reaction.
I probably won't believe
My
you.
favorite, which is problem number 1 with scientific reviewers. So those of you who don't know, the way the scientific review process goes is they put it out for anonymous review. You put your paper, you send it to an editor of a journal, and then they send it out to experts who review it anonymously.
This actually changed back in the 1970s, late 1970s, early 1980s. It used to be not anonymous review. I mean,
well, that's the thing. And then they were worried that senior people would hold a grudge against somebody and attack their career because they didn't like something they were publishing. Well, the problem is that anonymity in science has the same effect as anonymity does on the internet.
Yeah, so people write really nasty reviews and say nasty things.
Unfacts, untrue, unkind, unhelpful.
We're going to get a couple of dislikes on this one, aren't we?
I think anonymity is a big part of the problem.
Yeah,
it is in grant reviews and scientific reviews. So I would like to share a review that I recently had. I had submitted a paper. Actually, I was reviewing it, and then my review got reviewed by the authors. So this is one of my favorites. So I was asked to review a paper on something that I'm pretty knowledgeable about: instrumentation for muscle, how to measure muscle stretching and contraction, stuff like that. And they submitted a paper, and they were just sort of missing some calculations. So I did what I always do, which is, I'd like to help out if I can. Here's a couple of measurements you can do. You don't have to redo the experiment. Just do some calculations and normalize this and make sure you calibrate that. And I thought I was being helpful, right? So then I always sign. By the way, I don't know if you know this. I've never done an anonymous scientific review. I always sign my name, and I tell the editor, tell them it's me, because I think anonymity is bad. Right, so I like to, be who I am and say what I mean.
That doesn't sound like you at all.
Well,
saying what you need. Yeah.
Yeah. So anyway, I often don't voice my opinion, but every now and then I do. And so,
yeah, right.
Right, exactly. So anyway, I thought I was being helpful, and their response was just vicious. They're like, this guy's an idiot. He doesn't know. Well, first of all, I was a very junior professor at that time, so they were really unpleasant about the whole process with me. And then the end of their review was, well, now that we know who this idiot is, why don't you count up our degrees, like all the letters, MD, PhD,
QRS,
DDS, QRS,
yeah,
at the end of their name. And the lead author actually suggested to the editor that he should compare the 3 authors' collection of alphabet soup and compare it numerically to my number of degrees, and that he would see it would be self-evident who was right. Oh, by the way, I got a Band-Aid on. I think it's a Disney princess Band-Aid. Anyway, so they said, well, he said to the editors, just start counting degrees and you'll see who's right. Well, I don't know. I found, as a scientist, I find that pretty offensive. So I assume it's offensive. Is that offensive to you? I mean, counting up alphabet soup and saying, oh, I'm smarter than you because I have more degrees. I mean, I've got, 3 or 4 advanced degrees.
Of course.
I'm not smarter than anybody.
Well,
I'm just
of course,
an idiot.
a degree does make you smart. That's one of my favorite
No,
lines of
a
any
degree
movie.
does one thing for sure. It makes you poor.
Well, yeah, that's true. But one of my favorite lines of the Wizard of Oz, all-time favorite lines is when the wizard says, "You don't need a brain. You have a PhD."
In a brain, that's right. It's a piece of paper. Well, it's a lot more than a piece of paper. It's learning a lot of important things about something. But degrees don't assure that you're smart. And the fact that an author of a scientific paper would say, well, my approach to this must be correct and I must be right because I have more degrees than anybody else, that I think should lead us into the rest of this discussion, because it tells you how most academics are thinking. Hey, I have all this status and all these degrees, so I can define what's right and define what's true. And a lot of scientists think that. And that's a big problem in science now. So
is that the end of the story?
That's the end of my story. What I did was I wrote back to the editor and I said, I'm not quite sure how to answer that, but I mean, you can look it up in a basic textbook that what I said is exactly right. It's nothing. I was just trying to be helpful. It was nothing. I didn't think it was controversial at all. I was just trying to be helpful. And this guy came back at me saying, well, you just don't have enough degrees. I have more degrees than you do. So I was like, I'm no longer sure how to help. Is exactly what I said to the editor. So, I don't need to review this anymore because I can't help.
That's pretty. Yeah. The point is, people start going down these holes. they start going down the rabbit hole.
Yeah, I was
and
going to say a generous term. Rabbit hole.
They start doing things a certain way, and they can't get themselves out. Case in point, one of the very first reviews I saw was when I first started working in a neuroscience lab back in the early 1980s. A really long time ago. And the lab I was working in was in this battle royale with another group of neuroscientists, and who stated on the review of a paper that everyone knows that anesthesia does not affect the nervous system.
Right.
So we were studying the nervous system, and we were making the argument, and we were showing differences between anesthetic and non-anesthetic. And believe it or not, there was a big issue in this particular world that anesthesia makes no effect. Oh, come on. And this one group, they went to such extremes to show that anesthesia did not have an effect on the nervous system that they basically, they did a study where they were recording from the brain, and they gave animals 10 milligrams per kilogram of ketamine. Now, ketamine is a very powerful anesthetic. 10 milligrams per kilogram is a lot. You basically just about killed the animal, and you have to hit it with a hammer to get anything to record.
Right.
Now they took the 10 milligrams per kilogram, and they compared it with 100 milligrams per kilogram, and they said dead versus deader. There was no difference.
Yeah, you didn't make him more dead once he was dead, and therefore you had no effect.
And we showed differences between 0 and 7. And they said,
no,
everyone knows you're wrong. So everyone knows there's a huge, that you're wrong. And we actually did the dosimetric study between 0 and 7 and showed, no, there's significant differences there. And you guys are really doing some bad things because you're just wasting time, wasting experimentation, wasting taxpayer dollars to do experiments on dead animals. But, that was one of the first things I got exposed to.
To anybody, this should sound ridiculous, but when you're a scientist, you're like, oh God, whatever. A lot of science is going through a really dark period now. I've mentioned it before. I'll mention it again. Somewhere between 75 and 90% of all cancer research is absolutely not repeatable. It's not replicable, which means you can't really rely on it for anything. So there's deep problems with science, and one of them is this review problem. We get the same kind of stupidity from reviews on grants where they'll tell you, that doesn't work, you can't prove it. That doesn't work, you can't prove it. This is what happened to Mark. Doesn't work, you can't prove it. You can't prove it. You can't prove it. And the very next review was, everybody does this. That's not even a new idea anymore.
Yeah,
exactly. So it goes from it goes from one end of the spectrum to the other.
we basically the first few grants where we put stuff on the brain gauge and to try to get funding, people said, "Oh, this is really novel. That's nice, but you don't have enough data. You need to have a publication." And this was for a review process. So supposedly you didn't need a publication.
Oh,
for.
yeah.
And so we got a publication, and we went in twice more. Got a couple of publications actually, and go in back for funding. And they had told us, "You're not." The first round they said this is not novel. It's not, or it was very novel. And then by the time we were getting close to getting funding, and it had enough data, and had enough publications, they said it's not novel.
Yeah, so this
everybody's doing it.
I've had a huge number of bad reviews, which is weird because I think my funding rate is 55 or 60%. So more than half the time when I write a grant, I get it. So it's unusual for me to not get a grant because I don't shotgun grants. I don't put out like 20 a month or something like some of these people. I put out 1 or 2 a year at most, not even any recently. But many of the grants that I've gotten feedback from, especially for like foundation awards, and in particular foundation awards where some academic has kind of insinuated themselves in and they're sort of controlling it. They'll keep telling you, you need more data, you need more data, you need more data, and then you do all this data collection essentially on your own for free, hoping that you'll eventually get enough data that they'll pay you and pay you back. And then you cross this threshold where they say, well, that's not even research anymore. You've already proven it. What do you want money for? You've already done the work, It's like, and you can send them back their letters for the last 8 years or 10 years saying, look, you keep telling me to do more and more and more. So I did more and more and more. Are you going to fund this or not? And they're like, well, no, we're not interested in that anymore. And you've already finished it, do something else. There's no space in between where you've done just enough that they still consider research. No,
it got to where we used to have to. You got to be very careful when you apply. You're applying for funding, particularly at NIH, not DOD, but with the NIH, you pretty much had to fund. You could only ask for funding for things you've already done.
Oh, that's a big problem.
Because you have to show them just a little bit.
You have to prove that it works.
And
so it's research, right? So you have to prove it works. And it's like somebody not letting you play a game of poker until you show them your hand. It's a real hand. There's real cards there or something like that, and I've got a straight flush or something. Oh, okay, you're good to play then. No, it's like research is risky, but a lot of people have been complaining about research, and then they've been regulating it the wrong way. They're saying, well, you have to prove that it has direct medical relevance and that you have to prove that it'll work. And many times I've written back, well, that's not research anymore. And then
no, and you have to completely prove that you can do what you can do.
And then once you prove you can do what you can do, then it's like, well,
then you're on the
look for
pathway to saying, oh, you've already done it.
Yeah, it's a big problem.
So I wanted to get the wording right on this one. This was
some of these are so ridiculous. I can't even remember them.
Well, no, it's a direct quote of a recent paper. So the first thing I told you was from the 1980s. This is now, just to show it hadn't gotten any better, this is from a recent paper that just getting published now. Getting published. So we got over this big hurdle. Now, tell me, how we got over this hurdle. I don't know. But the reviewer said, you are making a huge assumption when you state that brain function is altered by concussion.
So this person is saying that the concussion, which is more or less defined as a change in brain function, that we can't even see it. So we're not talking about a lesion or anything, right? Necessarily. I mean, it's wrong at every possible level.
Yeah, so basically,
they don't even know how to unpack that.
We had brain gauge scores on the paper showing.
And that's a reviewer that's been
supposedly
vetted and is an expert in the area and has been chosen by an editor who's knowledgeable about you and your publications, your funding and everything. They would come up with a statement like, "You haven't proven concussion impacts the brain," but you hear this kind of ridiculous stuff all the time.
Let's see. We've got quite a few ones.
I can't go through mine like Mark is because it'll give me a heart attack. I'll just kill somebody.
This was pretty good.
Nope, I gotta stay away. Okay, hold on, breathing.
This was pretty good because we were given it. We'll want to go through a couple of these. I don't want
my calm space.
I don't want. We'll have to keep Bob in his happy place for way too long.
Happy place. Safe word. No grants. No grants.
Yeah.
Okay.
Well, we'll go through. I presented some data a couple years ago, and this was at a private group, and they were putting together a clinical trial for a drug for chronic TBI. And so I was showing some data that we had on patients that got better from chronic TBI from a couple of different things. And these were, even though it was a small group, fairly prestigious people there. But one of them was the former head of all things related to traumatic brain injury at the NIH.
Oh, yeah.
I won't mention his name, but you can look it up.
Yeah.
But
who's been in charge of traumatic brain injury for years?
So it's showing data, from that we obtained with the brain gauge on a lot of different patients and I said, okay, this was a experimental protocol, and we were going through it, and all these patients were getting better.
I remember this one.
Patients got better over a course of 2 to 3 months, and we were showing, oh yeah, everything looks better. And he's like, wow, this is really, really good. And then he said, what? Just tell me, what drug were they using?
Oh yeah, I remember this one.
And I said, well, this was not a drug. It was pulsed electromagnetic field. And he looked at it and he goes, oh, well, that changes everything. He said, the reason the patients got better is because they wanted to get better. Not because, like, most of these patients had chronic TBI for years.
And really
tried everything and wanted to get better for a long time.
Tried everything and nothing
all of
worked.
A sudden, this particular treatment worked, and they got better because
they wanted to. Right.
No other reason.
I get grumpy because I want to. I know that works. It works 100% of the time.
Yeah.
All right. I was thinking we'd keep this one short. What do you think?
I think so.
We got plenty to be grumpy about. We'll be making a lot more of these.
Those are the top three.
Those are the top three. Bob and Mark's top three on idiotic scientific reviews. All right. We'll see you later.
All right. Bye.